Hey everyone, I'm Scott Walkinshaw. As mentioned, I work at Shopify, and I've been working on our GraphQL APIs, and I'm going to be talking about designing GraphQL schemas. So what we're going to be doing is kind of running through a design tutorial. We're going to be taking a sample e-commerce feature and seeing how to implement and design it in GraphQL. So this talk is based on concepts and best practices that we've developed over almost 3 years of using GraphQL at Shopify, and they've evolved over time, and they're probably going to change more in the future. And this talk is going to contain a lot of design rules that we use internally at Shopify. And even within the company, we still question these, and they evolve over time. No rule can apply 100% of the time. So don't just take all these rules and kind of blindly copy and implement them. Pick and choose what you like, and change them if you want. So I mentioned before, we're going to implement an e-commerce feature and see how to design it. Let's imagine we work for a made-up e-commerce company. Maybe they even have an office like this one. So let's say we already have an existing GraphQL API, but it doesn't have much yet. Let's say we expose some information about products, and we just want to implement a new feature called collections. Collections are just a method of grouping various products. If you sell clothing, you might have a collection for t-shirts, pants, etc. And this is what a UI might look like for creating the collection. Just to give you an idea. And just so you make note, in the collection type, let's say we have two types of collections, manual and automated. We'll talk more about this in a bit. This is what a simple database diagram or kind of entity model might look like. You have collections on one side, you have products on another, and this can be a many-to-many relationship. So in the middle, you probably have a join table called collection memberships. And let's say you have some classes in your application. It might be designed like this, where you have a base kind of abstract collection class, and then you have the two types of collections that both inherit from it, so manual collection and automated. So now that we've seen how we might implement collections at a very high level in the database and application, we can start creating an initial GraphQL representation of it. So this is pretty close to the tables and models I've shown so far. At the very top, we have kind of a generic interface called collection. And then right below it, you can see the two types of collections, automatic and manual, that implement the collection interface. Just leave that for 1 minute. So this is the exact same schema, just with some fields removed. We're just going to focus on kind of the core concepts for now, and I'll get back to some of the fields later. And a reminder that the collection membership type at the bottom there, that kind of models the relationship between products and collections. But from a semantic kind of business domain perspective, collection memberships aren't really useful. They're more an implementation detail. And that means it doesn't really belong in our API. So this is a schema with the collection memberships removed. Our API should expose the actual business domain relationship to products directly. So you can see that now at the very top there, the interface collection references products directly instead of the collection memberships. So this is just a slightly more simplified version of the schema. We also modeled the automatic collections and manual collections as two different types, implementing the collection interface. And this kind of makes sense because that's how it was implemented in code, if you remember. But again, from a business domain perspective, any differences between these two types of collections are basically an implementation detail. The kind of defining behavior that we want to capture here is that collections groups products, and the method of how it does that isn't that important to like an end API consumer. So once more, we've kind of reduced the schema down to what we care about. We can unify both the collection types and get rid of the interface into a single type called collection. This is much more simple and easy to understand. And when you design around implementation details, like say the database tables or the class inheritance, you kind of get stuck if the requirements change. If in the future, say we wanted a manual collection which also had an automated rule, we'd be stuck. Our design couldn't handle that. So not only is this simpler, it's a little bit more flexible. And this leads to our kind of first rule. Never expose implementation details in your API design. Design your API around the business domain, not implementations, user interface, or especially if you have legacy APIs that already exist. Your API is a different context and kind of level of abstraction, so you should design it differently than you would, say, a database or model. So here's a reminder of where we started on the left, and here's where we ended up at on the right. I mentioned I removed some fields earlier. These were just like scalar fields. And this is a great time to ask yourself, like, before we just automatically add these fields back in, we should question if we actually need it at this time. Just because, say, a database column, model property, or REST attribute may already exist, doesn't mean you should just automatically expose it in your GraphQL schema. Exposing a schema element, like a type, field, argument, for example, should be driven by like an actual use case or need. Rule number 2 is pretty self-explanatory, but it's easier to add schema elements than to remove them later, especially because you don't want to deal with breaking schema changes and have to update all your clients. So here is the schema with the restored fields that I removed from earlier. Right away after the ID field, there's 2 fields that start with rules. And the first is just a list of rules that are applied to a collection. These are like automated rules. You could say if a title has the word shirt in it, then it becomes an automated collection for t-shirts, for example. One thing to make note of, because we'll talk about this more, is that for the rules field, both the list and the elements within the list are marked as non-null with the exclamation mark. And we have some tips here, not necessarily rules, but tips that are great to follow. Is list type fields should almost always be non-null lists with non-null elements. And likewise, Boolean fields should almost always be non-null. The only exception to this is if you think there's some semantic difference between null and like an empty list. And just because a list is non-null, keep in mind you can always return like an empty array. That's still valid. So back to our schema. Those 2 rules fields are there. We're going to talk about the third field there. The rules apply disjunctively. Not a great name, it might be confusing, but it's also marked as non-null with exclamation mark at the end. And here we run into a problem. This is a rule that should usually or used to apply to only automated collections. So kind of how do we deal with this since we've unified collections into one type? We can make it just false for a manual collection, but that feels a bit misleading. And we could also make the Boolean field nullable, but as we just saw, that's probably not the greatest reason. It also, you kind of get into this like triple state. It can be true, it can be false, or it can be null. And it's kind of hard to reason with what each one of those means. And good news is we can solve both of these problems at once by kind of deviating even further from our underlying, say, application implementation. We can introduce a new GraphQL type called collection rule set right there in the middle. And this is often warranted when you have, say, 2 closely related and like intertwined fields. By grouping these 2 fields together in a new one, we kind of provide a clear semantic indicator that they're related for one thing, but our problems around nullability go away, because if you look back up to the second field up top now in collection, we can make this entire rule set field nullable. So for a manual collection, it's fine, this field's just null, it doesn't exist. For an automated collection, we know we're going to get some rules, and we're going to know if they apply disjunctively. So rule number 3, group closely related fields together into sub-objects. We internally kind of refer to these as like semantic types. They may not represent a class in your code base or a table in the database, but they can be a really powerful design tool to make your GraphQL schema clearer and easier to understand. And one hint of this is if you have multiple fields which start with the same prefix. So our hint of this was that we had 2 fields that started with the name rules. Next up is the products field on the collection type up top. Right now it's just returning a simple list. So in our JSON response, we'd have an array of products. Collections in our case could easily contain thousands or tens of thousands of products. So trying to return, say, 10,000 products in a single response is obviously going to lead to some performance and efficiency problems. So whenever you implement a field that returns a list or multiple objects, always ask yourself if the field should be paginated or not. Some questions you can think of are how many objects are going to be returned? Is there a limit in your data model? Almost any API eventually needs pagination, and often it's pretty much right away. So the most common pagination solution in GraphQL is probably connections from the relay specification. We use it at Shopify, and so that's how we're going to fix this problem, is the product field, which used to return a simple list of products, now returns a product connection. And so I highly suggest picking a pagination solution early on, sticking with it. Relay connections, as I mentioned, are probably popular, but there's some other variations you can pick as well. Rule number 4, always check whether list fields should be paginated or not. And again, this is just better to check at the start because it's very hard to change the fields type and migrate later on. Next field we come to, again in the collection type, is image ID. This field is a classic example of what happens when you try to apply REST design principles to GraphQL. In REST APIs, it's pretty common to include a reference to an ID or of other objects in your response. It's a way of linking together those objects. This is a major anti-pattern in GraphQL. So instead of providing an ID and forcing the client to do another request round trip to get information about the object, we should just include a reference to the image itself. In REST, this isn't really feasible because it would really inflate the response size. So on this slide, all we've done is change the image ID field to be called image, and it points to an image type. So we're just returning the image object itself. And for rule number 5 is to always use object references instead of ID fields. There's some exceptions to consider. If, in this case, like an image is like an internal kind of model in our design, but if you have like an external data source, maybe you only have an ID from that, it might be useful. And just to point out that in this situation, since it's GraphQL and you only ask for or you only get what you ask for, someone can still just ask for the ID off image. They don't need to get the entire image object back. And our last field to consider in collection is this body HTML field. It's the last field there, which isn't a great name for a field. It's really just an HTML description of the collection. So the first thing we can do to make this design better is just give it a better name, and we're going to rename it to description. Rule number 6 is pretty similar to number 1 about avoiding designing around your implementation details, but it's choose field names based on what makes sense, not based on the implementation, or especially what you've called it if you have an existing API. Like if you're porting a REST API to GraphQL, for example, it's a perfect time to kind of rethink about your field names. And we're still going to look at this description field, and the last thing we're going to choose is if string is the right type for this field. GraphQL provides a decent set of built-in scalar types, so think string, integer, boolean, but it also lets you define your own, which is really powerful. And this is a prime use case for that feature. So in this case, we've changed the description field to return a custom scalar called HTML. This is a good kind of semantic clue to clients that this is a string, but it's going to return HTML. You can even do some custom validation to make sure it's valid HTML, for example. So rule number 7, use custom scalar types when you're exposing something with specific semantic value. Just try not to get carried away with these custom scalar types from the start. And that brings us to the final type that we haven't looked at yet, and that's at the very bottom there, called collection rule. This is probably confusing, probably like each rule consists of a column to match on, say like the product title, an actual value, say or t-shirts, that's called condition, and the relation is something like equality or greater than or less than. And again, we're just going to first apply some better names. That last field can be renamed, and so should column. Columns are pretty like database-specific terminology. We can rename that to field, and assuming both field and relation in your backend or database, these actually might be modeled like as an enumerator. They probably have like a known set of values. So one thing we're going to do is we're going to convert these to enum types. An enum type is great when you have a specific set of known values. So in this case, the collection rule type in the middle there, you can see we just renamed some field names and also taken advantage of our 2 new enum types that we've defined. So rule number 8 is to use enums for fields which can only take a specific set of values. This makes life way easier on the clients since the list of values is now known and discoverable with less surprises. So instead of just kind of an opaque string where any value can come back, they can look in documentation or editors and see all of the values. All right, we're going to move on to some business logic. We now have a minimal but well-designed GraphQL API for collections. And there's a lot more features and details we could talk about, but for this section, we're just going to pick one use case as a demonstration. So let's say we have a product page in our app, and we want to know if a specific product is a member of a collection or not. Our current schema contains all the information necessary for a client to figure that out. In fact, this is some kind of pretty close to real but pseudo JavaScript code. This simply gets a collection and all the products within it. And then at the bottom, we're just iterating over all the products to find if one matches the product ID that we care about, say the current product we're looking at. The solution has two problems. The first kind of obvious one is that it's really inefficient. As I mentioned before, collections could have 10,000 products, and we would need to iterate over every single one of them to see if this matches. And each client would kind of have to do logic similar to this. It requires the client to write logic that could be duplicated or lead to different behaviors or bugs. So rule number 9 is that the API should provide business logic, not just data. Complex calculations should be done on the server in one place and not in the client in many places. Obviously, this applies if you have many clients, which is true a lot of the time. So what's the solution to this? We can add a new field called hasProduct. This field simply takes the ID of a product, and it returns a Boolean on whether or not the product is a member of the collection. The client doesn't have to write any code. All you have to do is call a single field, provide one ID, and get back a Boolean. This is a very cheap and efficient way of figuring this out. There's a quick follow-up rule to this, though. Always provide the raw data, too, even when there's business logic around it. Clients should be able to do the business logic if they have to, and you can't predict all the logic that a client is going to do. And oftentimes, it's a good practice to let one client implement the business logic in the first place. And then if it becomes useful or a real feature, you can move it onto the server and make it easier for any other client to use it. So far, our schema and examples have only dealt with querying and reading data, not writing it. This is where mutations come in. So following the normal RESTful or kind of CRUD pattern, which is create, read, update, delete, that'd be a really easy way to get started with mutations in GraphQL. We just have create, delete, update mutations for a collection. But this doesn't really fit with the GraphQL philosophy. So the main problem we run into is something like this update collection. We've already seen that a collection has many scalar fields. It has things like a title, description, but it also has relationships to products and rules. So on the surface, this looks simple, but think of everything that could be updated kind of under the hood. What about adding or removing a product, or adding or removing multiple products, or reordering of products, for example? So instead, in GraphQL, we can take advantage of GraphQL's features and split this mutation apart into kind of more granular logical actions. So here's a list of some mutations or actions we could have. Again, we still have some of the standard collection delete and create ones, but now we have collection add products, remove products, and reorder products, instead of putting those all in a very complicated update collection. So rule number 11 is write separate mutations for separate logical actions on a resource. If anyone's used to like Reacts and Redux, you can kind of think of these as being similar to Redux actions. So we're going to go back and focus on a single mutation, which is collection update, and we're going to talk about return types. Right now, this is returning, the type that's returning is collection. And this doesn't really give us much flexibility, though. We can only update either a collection or return null, but nothing else. The solution to this is to create and use a specific payload type for each mutation. Right now, this is just a wrapper around the collection itself. You can see the collection update payload type has a single field, which is collection. But one benefit is we can also make the mutation return type be non-null now. So rule number 12 is use a payload return type for each mutation. And now we'll actually make that payload return type a little more useful. So mutations can obviously succeed or fail, and often you want to provide feedback and errors on failure. So GraphQL already has support for like query level errors. Errors are built into its spec, but these aren't ideal for business level kind of mutation failures. These are often like validation errors. Like if you're trying to create a collection, say with an empty title, and you get back a validation error that says title can't be blank. So in our payload types, we include a user errors field. This is a list of errors. Now, as feedback on a mutation based on success or failure, we can either return a user error or not. If so we're updating a collection. If the mutation is successful, you get back a collection, and your user's errors is just an empty list. If it fails, you'll get back at least one error, and your collection, it can still be there in this case, but the key is that you'll get back some user errors indicating that the mutation failed. So rule number 13, mutations should provide user business level errors via user errors field on the mutation payload. The top level query errors entry is reserved for client and server level errors. One quick thing about user errors is like obviously that's something specifically Shopify that we've developed. It happens to be a pattern that's kind of growing around the community. We've seen a lot of people using it. Sometimes it's named slightly differently or has some different fields, but it's becoming such a common pattern that the GraphQL working group has actually considered kind of amending the spec to account for mutation errors. Rule number 14, most payload fields for mutation should be nullable. You saw this with the collection field, it was nullable. Since mutations can fail, the object being mutated can be null, which means we can't always make it non-null. Such as if you're creating a collection, if that fails, there's no collection to return. So we have to make that field nullable. So this is generally a good practice to make them nullable. So this presentation was based on an even longer tutorial. That's the link to the full one. We've developed it internally and kind of spun it out publicly. And these slides are available here as well. Oh, and yes, as mentioned, we're hiring. And thank you, that's it.
Hello, I'm Carl Daniger, and I want to show you a cool thing that I've been playing with for the last couple weeks. And it's primarily this little guy. So it's a package that you get if you're like in the Apollo ecosystem. It's called Apollo Link REST. It will allow you to call REST APIs from GraphQL client with little effort. It's pretty straightforward, and it allows you to get up and running pretty quick. There's a question as far as why you'd want to use that. Well, you don't have to rely on a backend. And let's say I just want to use GraphQL by myself. You can stand up a simple app and no server and start consuming REST APIs. There's some other benefits. So I think I talked about the no server stuff. There's like little infrastructure, and I'll get into that. And you can start mixing sources. So you can have like a unified infrastructure for all your endpoints. And you can also mix stuff like GraphQL endpoint, like internally and externally. Like if like you had your own services as well, for example, you could have that come in through the same GraphQL queries, and you can still use like Apollo Link REST. Data is also managed by Apollo Client, which gives you a whole bunch of other benefits. So Apollo Client, is everyone familiar with Apollo Client? Sort of, like one hand, a couple nods. Yeah, okay. So like you get quite a few things. Like Apollo Client will cache your results and give you synchronized data throughout all of your components in the app. It'll give you data consistency, and it will always know how to access your data internally. Once you set up a REST endpoint, you don't have to think differently when you're like trying to consume the data. And it removes like context switching between like different endpoints. It's like you can get everything through the same type of UI or like philosophies when coding. And what else did I miss? Yeah, like stuff that you get from Apollo Client for those that are not familiar is like optimistic UI, some pagination, error handling, server-side rendering, some fun stuff, and generally improved performance. So I have a very simple demo on Apollo REST Link. Let's say I'm looking for a new pair of red sneakers. So let's make a simple sneaker recommender app. So here's a REST endpoint that can take a bunch of different parameters like color, type of laces, if your feet smell. Who knows, like maybe there's sneakers out there that are better for smelly feet. It's a fake endpoint, so don't try to hit this. I just made this up. So let's try to hit it with a curl. Just a heads up, this is a real world response that I had to deal with recently. So the response here, we can see that sneakers.co/recommendations, and then there's a query string, and takes color equals red. And what we get returned back is a JSON object with a single field called hits, and that hits is an array of strings, presumably IDs. What would this look like if the endpoint was in GraphQL? Like, it would probably be like a simple query like this, where you could pass in favorite color as a string, and then take that color and get your IDs from hits. Okay, so that's cool and all, but it's just REST API. So let's start consuming the sneakers REST API to find some cool red sneakers. So first, let's wrap our app with an Apollo provider, which comes from React Apollo. The import statement, second line. Apollo provider takes a client, which we will create. That's all we need to get to do for our app, and it will be able to start using GraphQL. Let's take a look at that Apollo client. So, does that make sense so far? Yeah. So like this would be like your app, I guess, and then a client. We're gonna write it right now. Is that it? Yeah. Okay. So we're gonna create a new Apollo client, and that's gonna take those two params right there, link and cache. So we're going to use a new in-memory cache, so that we're going to take that from Apollo cache in memory, which will store data right on the connected client. And for that REST link, we're going to define our REST endpoint and give it a name. So we're going to hit sneakers.co/recommendations, and from now on we'll just call it by sneaker recommender. Let's take a look at that original query again. So this was the basic GraphQL query. It accepts our favorite color, right? It takes it, we get our hits and stuff. So that's awesome. Now here's it a little bit different. So this is the same as that, except with a new directive. So that @REST. It's the same thing. Yeah, it's the same thing, except it has that directive there. So we can use REST directives at any depth of a query. So this one is like pretty much at the top. But once it's used, nothing in the nested, nothing nested in it can be anything other than data that is returned to us from that API. So in our case, we will have the hits array and then the IDs within that. The REST directive takes a type, endpoint, and path. So like if we hit sneakers.co/recommendations, which we defined in our Apollo client, that path is appended to the end when we're querying around adding our favorite color. The type is something used to generate the type name for the output we get back from our endpoint. I'll show you a little bit more about that later. The endpoint maps to what we define in Apollo client, and path is what gets appended. Our recommendations query accepts all that stuff, so we know that. And cool. Does that make sense so far? Pretty straightforward. Okay, so we get the same thing back from our new Apollo REST link. But what was I talking about with the type name? In Apollo client, most data is stored as a flat array. The Apollo client won't know if your IDs are unique, so it will use a type name plus ID to generate an internal symbol. It's usually like name of thing, so in our case it'll be like sneakers, some ID that you give it. Usually this is done automatically, so most of the time you will not have to worry about this. But we want our recommendations to be cached on that client. So this is what was returned to us, just a hits array with string of IDs, which is probably not good enough. Yeah, like as I'm changing colors, let's say in my app, and the hits changes, like our client won't remember this stuff when I go back from like blue to red to orange or something like that. The type name is used by Apollo client to identify things to recall from that cache. For us, like as I was saying, if we want to change it to blue, it'll give us object identification. We don't want to lose those results, so as we're like playing around with the app. This also allows us to be a little bit more strict with our types coming in from that REST endpoint. So in our Apollo client, we need to add a thing called type patcher to our, right there. So this gives us the ability to add a type name to some piece of data we care about that may be deeply nested in our response. For us, that data we care about is nested within hits, so it's just one level in. So we're just going to go data.hits.map. We're going to take that ID, and we're going to spit out an object that has underscore underscore type name recommendation and the original ID from that hit string. Again, spoiler, you won't always need to use a type patcher. It just so happens that the data that we care about is nested one level deep in this case. Let's take a look at what data looks like returned from this type patcher. So this is it. So before we had an array of strings, now we have an array of objects, and object has ID and type name. So that looks pretty good. It's pretty common for any app to need multiple data points. So let's add another endpoint that will give us more information about our recommended red sneakers. So there's another fake endpoint called ShoeDB. It can, I guess, help us get more information about some red shoes. The API is a little bit different. Instead of a query string at the end, like question mark color equals color, it takes a product slash and then some sort of string, comma separated list of IDs. Let's see what that response looks like. So this is what we get. It looks like we get some root level fields like page and underscore v, whatever that is, and a field called results with an array of objects of stuff we actually care about. Results is returning a lot of stuff. Let's say we only really care about ID, name, and photo for our sneaker app. So let's axe the rest of those fields in a GraphQL query. So here we have a nested REST directive and a new directive called export. The export directive allows us to use a particular field in the next REST nested directive. So let's see if I can explain this. So hits ID is from our original query, which comes from the sneaker recommender. Hits has IDs, and we're going to export each of those IDs as ID. Maybe I should have picked a different name, but we're going to use ID in the next level in, which is for this product, and we're going to hit our new endpoint, which is ShoeDB, and we're going to pass that path with the set ID. So what's actually happening here is it's going to loop over pretty much one product at a time. So it's going to hit product slash ID 1, 2, 3, 4, all the way down. I think that's pretty cool. So we get an object back with one field named results, which is an array of objects. Yeah, with the three fields we care about. Apollo client doesn't know how to traverse down into the results field to append a type name in this case as well. So we will need to add a new type patcher for that. So here's the second one. This is back in our Apollo client. We have type name of product, and then we use the spread operator to include all the fields we want back from our GraphQL query. We also added a new ShoeDB endpoint in our REST link and named it API right under sneaker recommender, since I guess that's where we're getting our product information. Let's take a look at what data is returned from our new product type patcher. Okay, perfect. Now Apollo client will know to cache all these results in memory on that client. So how do we end up using all this stuff? We're going to import our query file at the top and create a new query component that takes a recommendation query and variables. Favorite color comes in from props, and once our query has finished, loading is a bool that's provided by that query, and our data comes in via data. So like just query loading and data, and then we pass that in. So if loading is true, we load. We don't need to worry about catching any empty states within our sneakers component. we will return sneakers component, and we will pass in our recommendations to it. So what does data look like right here? So this is like an amalgamation of both those things happening. So we're going to get results listed like this, and everything looks good. We can see that there's a type name defined at the top level of every object within our results array, and with an ID that matches our product within it. So it goes like type name of recommendation, ID, and we'll match that ID product within it. This is primarily for Apollo caching. So if I'm changing stuff around and I go back from red to blue to red, there's no extra loading. It would just be like instant. So there are a couple gotchas. Apollo REST-Link doesn't completely give you a nice clean query. You will need to massage the data a bit to serve your needs. You will also need to deal with like first index of data dot something, for instance. Depends on what you get back. You can't really like change the structure of the result that's being returned from that endpoint. The type capture can be a hassle, but once you get it set up, it's great. Things cache like you'd expect, and you don't have to worry about it again. If the endpoint changes its structure, so if like the data I was dealing with, which is that single field hits, returning that array of strings, if they ended up changing it, so it was a different way of returning my IDs, it might be a little bit of a hassle because I have to go back and like you're at the mercy of the third party and what they may like how you designed your app initially. When you set paths, you may still need to escape characters in it, like URI encoding and stuff like that. Like I don't know if you guys have ever witnessed like crazy things with %Ds and S's and stuff. That still happens. It can be finicky depending on which third party you're using. Some are like more lenient towards that stuff. Each query runs one at a time. So for 100 sneakers, that's 101 queries. Batching, similar queries might be coming soon though. Last time I checked, it was on the roadmap. Nested queries, what I showed you, have their limitations too. You can't just say limit results to 3, for instance. If the first query, like the very top query, were to return 1,000 recommendations, it would loop over that second nested query 1,000 times. This happened to me recently, and it's caused some interesting CPU spikes in the REST API servers. If you want to control or let's say limit results, you can split your queries into separate queries. This will give you a little bit more flexibility with what you can do with that data. So I'm going to run through a simple refactor. So let's take a look at ShoeDB. So there's another thing that you can call product / and then that array of comma separated IDs, right? So fortunately, like we can do this. Here's our product query. So this is just this was the child REST query. Takes a string of IDs and passes it into the ShoeDB endpoint. Remember I named ShoeDB API, so when I say endpoint API from our Apollo client, that's actually hitting ShoeDB. This is our recommendations query that just accepts our favorite color. Okay, so this is the big one. Once our recommendations query has run and has a list of IDs, we pass those IDs into our product query. Now we can use something like Lodash. I think I'm using it. Yeah, take IDs of like take the first 3 and join them with comma, which gives us our comma separated list of IDs. Then we can do anything JavaScripty right there. This way we have much more control over what data we want to display and yeah, how that data gets loaded in. Yeah, so I think the main one here is goes query, and then you see this const ID is data.hits.map, and I'm just passing in all those IDs. And then when I return the second query with the product query, it's one accepting parameter is IDs, and then that's where I build my comma separated value. And then of course I'm passing in data.results into sneakers to show my sneakers. Cool. So as a quick review, showing you 2 ways to start using Apollo Link REST. Nesting REST directives and having multiple queries in a layout for more control. You can easily start to consume third-party REST APIs with little effort. It's pretty great. Give it a try and shoot me a tweet. Thanks.